In this problem, we have an equilateral triangle, and we know that the length of one of the edges is 1 centimeter. So the question is, how long is the height, right? Or how long is this line right here? What does that equal? So if you're ready to solve this on your own, pause it and then check your answer. If you want to see how I solve it, keep watching. So again, we're told this is an equilateral triangle. What does that mean? Well, equilateral, you can see right in the wording of the name, it means equal. So that means every edge or every side is equal in the equilateral triangle. And this also means the angles are equal, but here we can focus on the side lengths. Well, and in each side length here is 1 centimeter. So this is 1 centimeter as well, and so is this. This height that comes down, you notice, is dropping down, and the way we would often have this question worded, it would tell you or imply that it bisects or it's perpendicular to the base here, which means what? Well, whenever something's perpendicular, whenever one line is perpendicular to the other, it forms a right angle. So now that we know this is a right angle, you can see that this equilateral triangle is cut in half into two right triangles. And that means we can use the Pythagorean theorem, right? Whenever we have a right triangle, we can use the Pythagorean theorem to relate the edges or sides. Now in this case, what do we know? Well, we know that the hypotenuse is this length, and that's 1 centimeter. So c squared is 1 squared. What about a and b? Well, let's call this height b, and let's call this right here a. How long will a be? Well, since this line cuts the bottom in half, and the way they'll often say that is that it bisects the bottom, right? That means it's cut into two equal pieces, and since the whole edge is 1 centimeter, half of that is this leg of the right triangle, so it's 1/2 of a centimeter. So a is 1/2 squared, plus b squared is c squared. So what's 1/2 squared? That means 1/2 times 1/2, or 1/4. We still don't know what b squared is. And what's 1 squared? Well, that's 1. So I want to find out what b squared is, so I'm going to subtract 1/4 from both sides. And the reason I do this is, well, I know that b squared is something plus 1/4 gives me 1. So 1 minus 1/4 has to give me that missing something, right? I'm using inverse operations here. So 1 minus 1/4 equals b squared. And what is that? Well, if we take a fourth away from a whole, we have 3/4 left over. And b squared equals 3/4. But our goal is to find this height, this length. How do we do that? Well, we find the square root of b squared, which is b equals the square root of 3/4. When you have a fraction like this, you can break it apart and think about it as if it were the square root of 3 over the square root of 4. And now this is a little bit easier to deal with, and b is equal to what? Well, the square root of 3, we'll leave it as the square root of 3 since it's irrational. Think about it. 1 squared is 1, 2 squared is 4, 3 is in between, so there's got to be no whole number or exact decimal that gives us the square root of this whole number. And the square root of 4 is 2, but since 2 times 2 is 4. So that length, b, is the square root of 3 over 2. And again, look at that. I mean, if we have an equilateral triangle with a side length of 1, or an edge of 1, look how unfriendly the height is. And in fact, this relationship is really important for to explore in other triangles, especially, as you'll see later, for 30, 60, 90 triangles or other combinations. You'll get these really cool relationships by exploring what happens when one edge or side is 1 inch or 1 centimeter or any unit of 1. All right, hope